lads, we are streaming. Oh, I guess I was supposed to do a little bit of setup. Hold on. I guess I'll go ahead and share my screen while I'm doing that. But with the time difference here, it kind of works out. Oh, nice. So you're up at like 4 in the morning, and it's only like 10 here. All right. So let me go ahead and do a quick setup for today's wonderful little lesson. Wednesday workshop is at 3 a.m. where I am, so did it? True. That's actually so true, Ricardo. I was eating Chipotle at like 3 in the morning last night. So pretty much exactly what you're saying. It's so hideous. Um, hey, Courtside. What's up, Ngayo? Amethyst, hello, hello. MPI, how you doing? Ola Banji, what's up? Haven't seen you in a bit. Good to see you. Osliv Tuer, hello. Shiver and Supri, what's up? We even got Professor Meta in here. Let's go. The legend himself.
How are you? How are you? Good to be here.
Yeah, awesome to have you. Hey, Shiver. All right. What is it? 12:05. All right, time's flying. Yeah, what's up, Osliv? All right, so what do we got today? So today we got chapter 3. We did days 1, 2, and 3 in the last workshop. So today we're gonna do chapters 4 and 5. Um, so not a crazy day today, but we definitely have some pretty cool content that we're officially moving away from like the beginner stuff. So we covered basic things like variables, functions, structs, resources, but we're gonna start diving into more like the complicated topics. It's not that they're harder necessarily. It's just that they're definitely like a layer up. Okay. So we're gonna be that we're starting to do that now, and hopefully I don't explain this too bad. So we're going to be talking about resource and struct interfaces today, which is really on the topic of like security. So we're going to be spending a lot of time on just like the security of our contracts and making sure that we're not exposing things to the public. For example, like one of the things that we're going to touch on today is like when you have an NFT collection, why is it that I can deposit to your NFT collection but I can't withdraw from it, right? What are the reasons in the contract that that's not possible? So without further ado, let's dive into it. Also, I want to make a quick note that interfaces are something that apply to both resources and structs. It's just that in today's lesson, we're going to be focusing pretty much entirely on resource interfaces, but everything you learn today on resource interfaces is the exact same thing for struct interfaces. So just keep that in mind, okay? All right, cool. So let's do it. So, what even is an interface in programming? Interfaces are not, cadence specific. They're used everywhere in programming. Like I said here, interfaces are very common in traditional programming languages. And there's two main things interfaces are used for, at least in cadence. All right. It specifies a set of requirements that something has to implement, and it also allows you to only expose certain things to certain people. So this is sort of like a my best version of like a diagram. Is that you have like this box like a resource or a struct. So that's this box, and that's something like this, right? So you have a resource called the profile. That we're going to call it a profile for this lesson, and inside of it you have an ID and you have a name. All right. So this is like your box, and then you have an interface. Oh, oops, gonna get rid of that. You have an interface that sits on top of it. And the resource or struct, quote unquote, implements the interface, right? That's how you refer to it. So you can refer to implements as like the upward arrow pointing to interface. What's up, love the game? Um, all right, so how do we use, remember I said there's two things you use them for. You use them for, it specifies a set of requirements for something to implement, and two, allows you to only expose certain things to certain people. So let's focus on number one first. It specifies a set of requirements for something to implement. So what does that mean? Well, that's this section right here. So yeah, let's just dive right into it. So how do you even make an interface? Well, public resource interface, you put an interface, and then the name of it. So I'm going to call it like iProfile. So in other languages like Solidity or it's sort of like common practice that you put like an I before like the name of an interface. That way people that are looking at this type know it's an interface because there's an I in front of it. For some reason in Cadence, people tend to put profile public or something like this, or they tend to put more descriptive names like profile restrictive. I don't know why people like, you can do whatever you want really. For simplicity, I'm just going to put an I before it so we know it's a interface, but you don't have to do that. It's just like standard. Okay. So, like I said, an interface sits on top of a resource. Now, one thing that's pretty interesting about an interface is that you can't actually set types to values. So in this interface, for example, I can have a name, okay, and say public let name. But notice it's not giving me any errors about initializing it, right? I don't have to like initialize it in here, and in fact, you can't do that. It says cannot implement initializer in a resource interface, okay? So interfaces are not meant to be containers of data. They're meant to be like requirements or ways that you can expose things to certain people. So remember I said in this diagram that a resource or struct implements an interface? Well, you can do that by putting this little colon here and then the name of the interface. And you can specify multiple of them by doing like I profile, I other thing, like with commas. You can do that, but we only have one in this case. So if we look at this, everything is fine, right? Right now, everything's okay. But what happens if I add another thing here, like public let favorite, I don't know, favorite fruit, and I put like a string? All of a sudden we have a problem. And it says resource hello world.profile, which is this right here, does not conform to the resource interface iProfile, which is right here. So does anyone have any guesses why that might be based on what I said right here, using interfaces as requirements? Any guesses as to why there's an error here? Yeah, it's because the profile needs this variable, right? So inside here, if we do public let favorite fruit string, and I say, okay, self.favorite fruit equals watermelon, or I don't know, right? Then we're good, right? Because now this has the favorite fruit in it, and we've also initialized it, so it's perfectly fine. Now notice that if I were to change this to like integer, for example, it doesn't work, right? So it has to be exactly as you see it right here, right? Even if I was to put var, it doesn't work. It has to be let, right? So it's the exact same thing. So pretty cool. So that's one example, or that's this example. Using interfaces as requirements. Okay, that's the most important takeaway to get from that. So the second thing up top here was it allows you to only expose certain things to certain people. So that is this section down here, right here. So using interfaces to expose certain things, and this is mostly what it's used for. Okay, so um, we call this like actually, I'll leave that for another second. But anyways, let's go down here. What's up, Rom? Thanks for joining. All right, cool. So inside here, let's make a function. This is just for testing purposes. We're gonna call it. What do I call it in here? No interface and yes interface. Okay, so let's call it no interface, and it's just gonna be an empty. It's just gonna be an empty function, right? And inside here, what we're gonna do is we're gonna make a profile, create a new profile, and we're gonna say the name is Jacob. All right. So the name is Jacob. Now, because it's giving us an error, let's just destroy it below, right? We know why we have to do that now. And let's try and access some information. So is that going to allow us to log profile.name? Yep, totally fine. Is it going to allow us to log profile.id? Yep, totally fine. Can I log profile.favorite fruit? Yep, totally fine. right? So all these things, it's allowing me to log, right? There's no errors here, so I can access this information. And we don't have to put this here, but just because, let's also include the type here, just to better understand what exactly this type is, right? Now, let's contrast this with yes interface. All right, and let's do the same thing. Let's say let profile be create profile. Name is going to be Ram. All right, and then we're going to destroy the profile below. But this time, we're going to do something different. We're going to make this type a profile type, but it's restricted to iProfile. So this is how you write a restriction in Cadence. You put little curly brackets and you put the interface inside of it. Now, again, if we had multiple, you could do like, comma separated list, but we don't have that. So we just have one here. All right. So now our profile, right, that we have in this variable is restricted to this interface. So we know that this interface contains a name and a favorite fruit. So if we go down here, who thinks we're going to be able to log our name? Any yeses? Actually, I'm going to put a thumbs up in the chat. Um, if you think yes, then thumbs this up. If you think no, then thumbs this down. So we have a profile here, right? It's a profile that's restricted to iProfile, and iProfile has these things inside of it. So are we going to be able to log name here? Yes or no? So we have 3 upvotes and 3 downvotes. We have 5 upvotes now. All right. Looks like the upvotes are winning. The answer is yes, we're going to be able to. And that's because, right, iProfile contains name. So it's fine, right? Even if profile is restricted to iProfile, right, it's still fine because it contains name. Now, on the other hand, if we try to log profile.id, problem, right? Member of restricted type is not accessible, ID. So how would we fix this error? Anyone know? Yes, add ID to interface. Exactly. So if we add the ID to the interface, it works totally fine. Great job. So that is resource interfaces in a nutshell. And you're probably asking how we're gonna make this come into play in the real world, and that's gonna be answered next week on Wednesday, when we really dive into storing assets in our account and what that even means. But it's important that you understand this just for now. That resources are used as requirements and also as ways to expose certain types. All right. Yes. Okay. Cool. So let's go back and I'm gonna do one more example. So I'm gonna add a function in here called change name, and it's going to say new name is a string, and it's going to say okay self.name equals the new name. Let's make this var and this var. Okay. We have no errors. So right now we have change name inside the profile, right? So let's go to no interface and let's say profile.change name. New name is Raven, right? It works totally fine. But if we go down here and try and say profile.change name and we get new name Raven, it's not okay because it says member of restricted type is not accessible, change name. So the way to add to this, or the way to fix this error, is either to not do this, right, because it's not allowed. But as the programmer, if you wanted to be able to call change name, even when it's restricted, you could go up here and add it to the interface. Now, the way you add a function to the interface is you do the same exact thing that you would normally do. You just don't open brackets, so you don't do any of this stuff. You just leave the type right there, just like that. And now it's okay. Like now we can call it right here. Cool. So earlier in the call, you mentioned the concept of withdraw and deposit in the contract. What do you mean by that? So what I meant by that is like what we're going to get to later in the course is NFT collections. Um, and in NFT collections, you can withdraw and deposit. Like as me, I can deposit to your collection, for example. But I can't withdraw from it, right? For obvious reasons, because if I could withdraw from your collection, I could just steal all your assets, but I'm allowed to deposit. And there's a reason for that. And the reason behind that is because of resource interfaces. From a very like broad point of view, it's because a collection, right? Imagine profile was collection and this was I collection. It's because I collection has the deposit function inside of here, but it doesn't have the withdraw function. Because if it had the withdraw function, I could just take all your assets. Um, and I'm only allowed to access your I collection because that's what you expose to the public. So we will get to that, but that's what I meant by that. No, no, like NFTs. So like if you have like your floats collection, right? So you have a different collection for every single NFT. So like if you have like floats, for example, think about it in terms of that, like depositing and withdrawing floats from your collection. Usually in when in like the flow blockchain world, when people say collection they mean NFTs, and when they say vaults they mean tokens. So if you ever hear vault, they're usually referring to tokens. Yeah. All right, so anyone have any questions about this before we move on to a totally different topic? Alrighty, sounds like we're all good. So I'm going to basically delete everything here because the next topic is totally different. All right, on to access control, which is I would say access control is like definitely mind-boggling, but it's kind of cool actually. It's my favorite. It's my favorite lesson to teach by far. Sorry. So I gotta remember how I use this type of thing. Okay. Um. Okay. So yeah, let's do it. So okay, so we're gonna talk about something called access control now. Um. So access control is extremely important because it's basically how you add security to your smart contracts, and it's how you make sure that you're only exposing certain things to certain people. So that's why I wrap it in the same lesson as resource interfaces. But access modifiers are really all about like the security of your contracts. Um, so yeah, let's dive right into it. So I from what previous students have told me is that this usually takes a couple like minutes, like 20 minutes for you to like actually understand what the heck I'm talking about. So for the next like 20 minutes, you're probably gonna have no idea. But I think at the end of this lesson, in the next like 40 minutes, we'll be in a much better spot. So just hang with me here for a little bit. Okay. So access control is all about how you read and write from certain variables and certain functions. So where in the contract are we allowed to read a variable, and where in the contract are we allowed to write to a variable or change it, right? When we say writing, we mean like change it. And similarly with transactions and scripts, right? In what scenario are we allowed to read a script, or read a variable in a script, and when can we, write to it in a transaction, stuff like that. So that's where access control comes in, and more specifically, something called access modifiers. So remember how this entire course, when we make a variable, I've been telling you to just like ignore pub. Well, this is what we're going to talk about now. So this is called an access modifier. Um, that's just what it is. And there's a lot of different access modifiers in Cadence. So let's just go ahead and define this really quick. The self.greeting equals Jacob so much smarter than you, right? Statement of fact. So this pub right here, This is an access modifier, but there's a lot of different ones. There is access all, which means the same thing as pub, which is kind of confusing. There's access contract. There's access account. There's access self. There's pub set, and there's also private. So yeah, there's a lot, and we're gonna go over what each of those means today. Cool. So yeah, let's just open this diagram. So this diagram, by the way, when we talk about access control, this is like your best friend, like ever. Like this is like your number one bestie in the whole world. This diagram, it'll help you contain all the information you'll need in one little spot. Um, and this also isn't my diagram, by the way. This is from Flow's documentation. It's like one of the only parts of the documentation that I think is like actually good. Um, but anyways, so just to provide like a little bit of context here, um, we're going to be talking about how to read and write to certain variables and under what conditions those are allowed. So for the purposes of this lesson, we're going to completely ignore these first four rows. And the reason for that is because this is all let. So remember, what I mean is like, you can either have var or you can have let. And this lesson doesn't really make sense when we talk about let because you can't write to let, right? It's a constant, so you're not allowed to change it. So it doesn't really make sense to cover this use case. So we're going to make everything var, but just know that everything we talk about in terms of like writing to a variable doesn't apply with let, right? Because you can't change it. But when we talk about reading from a variable, it's the same thing. So it makes sense for us to talk about var, and then you can figure out let on your own because it's the exact same thing except writing. All right, so let's start right here on this row right here. So this is the access modifier is pub or access all. So pub and access all are the same exact thing. And in fact, usually the playground actually, yeah, so way back in the day when the playground was like initially written, everyone used to write access all. But I've never seen a Cadence developer ever in my 2 years of coding Cadence, no one has ever written access all. Everyone always writes pub. So you can write either. Maybe it's more helpful for you if you write access all, but I would always write pub if I were you. Okay, so that's number one. But what does pub actually mean? Well, it means that there's a read scope and there's a write scope. The read scope is where you can read this variable, and the write scope is where you can change or write to this variable. So with pub or access all, the read scope is all. Now, what all means is you can read this everywhere. You can read this in a script. You can read this in a transaction. You can read this in another resource, right? So if I have a resource here called test, I can say public function read greeting, and I can return a string here. And what this does is returns hello world greeting, right? So I can even read the greeting right here, right? So you can read this truly everywhere. That's what that means, all. Now, the write scope is current and inner, and this is where things get a little confusing. So let me actually bring up Excala draw so I can start making some helpful diagrams. So let's make a box, okay? And this is going to represent the smart contract. Now, over here, you have transactions and scripts. So this is a script, and this is a transaction. All right, just like we have in the playground. So here's the smart contract, and then we have transactions and scripts as boxes over here. So when we write a variable right here, public var greeting string, what all means is it can be anywhere. It can be out here, it can be over here, it can be inside of here, it can be over here, it can mean anything, right? When we talk about current and inner scope, that's a little different. Okay, so what this means, current and inner means it's only within. It's only within the current scope. So you cannot go outside of it, right? You can't go outside. All right. And the best way to think about this is like usually in like a sort of like a box model. So when we have something like this, right? The greeting is right here. Okay, so the greeting's right here. Now the resource you can think of as like another box. So the resource, right? This is, what did I call it? Test resource. So this is the test resource. This is like another box, all right? So current and inner for this variable, because it's at this level, means in here, but it also means in some function over here or anywhere over here, right? But if we were to make a variable inside the resource called public var a number is an integer, the current and inner for this one means within here. It does not mean outside of here. That would be all scope. Is this making sense at all? Like a little bit? So, for example, if we have like a public var number here, right? Like this, you can't ever read this out you can't ever write to this outside of here. Like change number. You can't do this at all. You can't change it in here because it's pub. So the write scope is current and inner. But because the read scope is all, you can read it in here. Wait, where am I? You can read it in here. So again, if we like pretend we had a reference to the test here, like reference to test, we could read number, but we can't write number. All right, so I hope the illustration is helping. And again, as we work through this more, you're going to understand it more, I promise. But let's just keep going. So let's try another one. Let's try public set. So public set. Let's get rid of this error for now. Right? Okay, so let's try public set. So public set means that the read scope is all and the write scope is all. So for public set, that means that we can read it anywhere and we can write it anywhere. All right. And similarly, if var number was now public set, we could read and write this anywhere we want. Cool, right? So let's try another one. Let's try access. We're not going to talk about access contract, and I'll explain why at the end. Let's try access contract. So the read scope for access contract is current, inner, and containing contract. Wow, that's interesting. So let's change this back to pub and let's make the number here access contract. And just to get rid of the error, I'm gonna add an init function here. Delf.number 0. Okay. So here we go. We now have a variable called that has access contract scope. So again, let's go to the read scope. It has current, inner, and containing contract. So what that means is, let's get rid of these errors and change this to access contract. Right? We can read this in the current and inner scope. So this can be read inside of here, right? Or the containing contract. So we can also read it outside in anywhere in this contract, but not in scripts and not in transactions. Now let's go to current and inner scope, right? So the write scope is current and inner. So we can only write to it inside of here, not outside here. Does that make sense? So if you want to, go back to the course, and if you scroll down, right, there's a bunch of really helpful diagrams that explain exactly what each of these mean. So all scope, right, it shows you what all scope means for this public variable, right? And it even shows you a box here. Whereas the current inner scope, right, public let var, shows you what the current inner scope is for var here. Same thing with these. I'm using Excalibur, Professor Meta. Yep. All right. I also realized there's like a slight. I tend to be a absolute perfectionist, so it kind of bothers me when something's a little off. But oh yeah, no, this is correct. Okay. Okay. Cool. So without further ado, I think the best way to really understand this is to do the quest. Because the quest is, if we work through the quest together, that's usually how students understand this the best. So I'm going to paste in a whole contract. And I love doing this, by the way, because it's almost like a puzzle. Like there's like different areas. I kind of made it like a game, and we're gonna crack the code. And let me also copy in the script here. Okay. So let me go ahead and deploy this. And yeah, so we're gonna spend the next 20 minutes or so playing a game, and then we're gonna be done. So, just to sort of walk through. By the way, does anyone have any questions first? Anyone have any questions? Also, the last one I forgot to talk about was access self, and that's current and inner for both read and write scope. But we're gonna see this in the quest today. Oh yeah, remember I mentioned earlier, by the way, that I mentioned that public is the same thing as access all. Well, it's also funny because private is the same thing as access self, but nobody uses private. Everyone uses access self, but nobody uses access all. They use pub. So it kind of makes no sense, but yeah, that's what we do. Um, so inner means inside the box, whereas contract means anywhere inside the contract. So inner depends on where you are, because if you're here, then inner means in here and also over here. Whereas if you're already inside the box, it just means inside here. Whereas contract means everything in the contract. Current and well, not really, because they're when you still look here, they're always together. So like you never see one without the other. Current refers to like the current level. Let me get rid of all these. Lot. But current refers to like the current level. So when this greeting is at this level, current and inner means this is the current level, and also like over here, and then like this is the inner level. But they're kind of the same thing because you can't write code that reads on the same line, if that makes sense. Like for example, when we have a resource here, like this is like a box, but you also draw boxes for functions. Like this is like a function call, and it's the same thing here. Like this is like the inner scope. So they're kind of the same thing. Contract. Funny enough that this is access all here. I'll just leave that. Contract, sum contract, and inside here we have a struct called sum struct. So the sum struct has 4 variables. It has a public set variable a pub var b, an access contract var c, and an access self var d. Now remember again, this is the same thing as private, but for some reason no one uses that. They all use access self. Um, then we have 3 functions. One is public function public func. One is access contract contract function, and one is access self private function. All right. And then we have a few areas. We have area 1, which is inside of a function. We have area 2, which is inside of a function inside of another resource. We have area 3, which is a function inside the contract. And then we have area 4, which is a area inside the script. So lots of different areas to figure out. And in each area, we're going to figure out which ones we can read and which ones we can write. Okay, and hopefully this will help teach you this kind of stuff. So yeah, right. And then we simply store a test struct in the contract just so that we can play around with it. All right, so let's go ahead. I don't like the extra. Let's go ahead and let's start with area 1, right? So think about this as a box, right? So right now, let's actually draw up a little diagram here. So we have a box. Make this a different color. and this is sum struct. Right? This blue box is this sum struct right here. All right, and inside of it we have 4 variables. We have pub set A, pub B, access contract C, and access self D. Right, and then inside here we have area 1. Right? And I'm pretty sure actually this is exactly what I already drew up in the course. Oh, okay, close to it. But anyway, so let's make this a different color, and this is going to be area 1. Right? So this is exactly where we are right now, right? This is area 1, okay? So again, we have the sum struct, and we have area 1, which is inside of another function, just like we drew here. So let's look at each of these. Public set A, right? Public set. Okay, let's go to public set. Boom. The read scope is all. So who thinks we can read who thinks we can read A in area 1? And also, because this is going to be very collaborative, like, just type yes or no in the chat. And we're going to be doing a lot of this back and forth. So we only have 4 yeses so far. How about this? You only get a float if you participate in the chat. Because even if you don't know the answer and you're super confused, I promise you it's super helpful to put yes or no in the chat. So far, Ngayo, Professor Meta, MPI, Joka, and DD are getting floats. All right, nice, good. So the answer is yes, right? So the answer is absolutely yes. We can read A inside area 1 because the read scope is all, and that definitely includes this area, right? So by induction, we can also figure out that we can read B inside of here because B also has all, so obviously it's the same thing. So self-explanatory, right? We can read A and B in here. What about C? So C has access contract. So access contract says you can read it in the current, inner, and containing contract. So can we read C in here? Who says yes or no? All right. We got a bunch of yeses. Yes, 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 yes. So the answer is yes, absolutely. So you can read C in here because it has current and inner, and this is definitely within the current and inner scope of C. Right? Perfect. And then it's very similar with D. It's access self, current and inner. So we obviously all know that you can read D in here as well. So if we go back to our answers, so read, we can read A, B, C, and D. Perfect. Now let's figure out writing. So let's go back and look at the write scope now. So we just decided, right, that we could read D inside of there, and D had current and inner scope. So again, just by induction, we can figure out that all of these write scopes will also work because public set has all, current inner, current inner, current inner, and current and inner. So, and we already know that the area 1 is within the current and inner scope of these variables. So obviously, we can conclude that we can also write all of these ones in there as well. So A, B, C, and D. Right? And if you were to try it out, like for example, if you were to log self.a, and you could also say self.a equals something else, right? Right? All these things will work if you try them out individually. All right. So that's area 1. Now we're going to go to area 2. So area 2 is in a totally different area. So let's draw another box, different color, and this is going to be some resource. All right. And inside of this box, let's end this a little bit. Inside this box, we have another function, and we're going to make it purple again. Let's make this purple, and we're going to call this area 2. All right. So again, we're looking at some resource, which is not, this is the struct, right? The blue box. The resource is outside the struct, and we're in this function right here called area 2. So that's exactly what we drew right here. When it says, what's the scope self, the entire contract or where it is declared? are you referring to access self, or are you referring to like this kind of self? Oh, so self.a refers to the scope right above it. So in this case, self.a is referring to the scope right above it, which would mean this one. So for example, if we had a public var a here, right, this a is 2 scopes above this one. So it's not referring to that. It's referring to the one right above it, which is this one. It's actually a pretty good question, because hopefully that helps you understand like what scope means and what self is actually referring to. Sweet. So now we're at area 2, right? So things are getting a little more tricky now. So let's go through the list again. So let's look at public set A here. So public set has read scope and write scope of all. So who thinks we can read and write A in area 2? Yes, right? Exactly. So what we can basically conclude, like so that we don't have to keep going over all, is that you can always, if it has all, the answer is always yes, right? So it's actually super easy. So let's go ahead into area 2, read. We know that obviously A, and also we've concluded that the writing is also A, right? So it's pretty easy for A. And if we go back, we can also see that, pub has read scope of all. So the answer is always yes for B as well when it comes to reading. So let's go back. Now we know that public has a current and inner scope for writing. So who thinks that we can write to B in area 2? So far we have 2 yeses, 2 nos, 3 nos. Uh-oh, the nos are taking over. Meta says no. X for X changed the answer to no. Let's see what Brett has to say. No. So the answer is no. Um, so when we look at B, right, B has current and inner scope. And what that means is that, that's within here, right? But that is definitely not over and out and back in here. So no, the answer is no, you cannot do that. So we cannot read B there. So we can also figure out that we cannot write for C or D either, right? Because they also have current inner. So for writing, as far as writing goes, it's just A, right? That's the only one we can write to is A. Um, Now, when it comes to reading, it's a little different because of access contracts. So we already know we can read and write to A and B, but what about C? C has current, inner, and containing contracts. So who says we can read to? Who says we can read C here? Joka says me. MPI says yes. Meta says yes. Engayo says no. DD says no. All right, the no's are coming back. MPI is justifying. So the answer is you can, yes, you can read, because containing contract means everything in the contract. So you can always read as long as it's in the contract. And area 2 is definitely in there. So the answer is yes, that we can read C, right? And then to conclude, when we look at access self, we know access self is current and inner, and obviously that's a no, right? Gut never lies, dang it. True. Trust your gut. All right, so that is the answer for that one. All right, so cool. On to the next game, area 3. And right. All right, this one should be pretty quick. So let's try and figure it out again. So in terms of reading, obviously we know A and B because they're both all, right? And writing we know is obviously A because it's all, right? Um, so no, Meta. So the point of access contract is to keep it out of the transactions and scripts. It's only the contract. All right. So we can obviously fill these ones in. Now let's check out C and D for reading. So for C, right, it's containing contract. Now, by the way, where we are right now, we are over here. So we are in a function called quests are fun. So this is a function called quests are fun. Make it a new color. All right. So this is where we are right now. So current and inner, nope, definitely not, right? Because current and inner is only over here and like in here. So we cannot read that over here. So it actually ends up being very similar, right? We can read C here because it's the containing contract, right? Area 3. I guess we can also just call this area 3, right? This is area 3 is definitely in the containing contract. So the answer is yes, we can read C, but this is the answer for area 3. So it's actually the exact same thing as area 2. All right. So that is area 3. Any questions on this one before we go into the last one? All righty. On to the last one. Area 4. Woo! The last challenge. Now things get a little different here. Probably tell. All right. So I know that these are going to be obvious answers, but who thinks that we can read A and B here, right? So A and B have all. So who thinks that we can read A and B here? Got a bunch of yeses. Yep. So obviously A and B. Now who thinks we can, who thinks we can write A here, right? So A, who thinks we can write? Got a couple yeses. Got a no. Yes. Joka says no. Uh-oh, people are changing their opinions. Aha! I gotcha. Yep. Yep. Nice. Couple you caught on. Clap, clap, clap. So the answer is no. We can't write A here because it's a script. Gotcha. It's kind of a it's kind of a trick question. The answer is like yes, but it won't do anything, right? Like you can change A here, but it won't do anything because it's a script. So the answer is no. Snowmobiles is LOLing because I've now done this 4 times every single boot camp, and he's had to sit here while I do it, but I don't care. It's still a great joke. So screw you. um, so good, but I'm glad that some of you caught on that it was sort of a trick question. Yep, and and Bam too. Yeah, Bam always Bam's always sitting here while I'm going through my tricks. That's the one trick I have up my sleeve the whole boot camp, and I can't wait to do it every time. That's why I said it's my favorite lesson. I wasn't lying. Um, so yeah, we can't read anything, or we can't write anything. So the answer is we can write A, uh, but not really because it won't do anything. All right. And then in terms of reading, right, we have A and B. Now, who thinks that we can? Let's go to C now. So C is access contract. So access contract is current, inner, and containing contract. So who thinks that we can read A in the script? Half a point? Yeah, you can have a point, Meta. So Joka says yeah. MPI says no outside. No. Some people are thinking. Meta says no. So yeah, the answer is no. You can't because containing contract is only in here. Oops. Right, and that's outside. So no, you can't. So the answer is no. And then obviously the answer is no for D because D is even more restrictive because it's just current inner. So like I said, this concept is really hard at first. And when I was initially showing you, like I know everyone was like freaking out, like what the heck is he talking about? Jacob's terrible. But when you really work through it a little bit, it's actually not that bad. And all of you are pretty much getting it at this point. So Good stuff. So yeah, that's on access control. And I hope that this sort of helps you understand a little better about when you should be. Jacob, that is the best. Yep, that was your first quest. Exactly. I'm glad the teachings are engraved in your brain. All the different syntax is confusing though. Thoughts on why they have different ways to write access modifiers? Well, I think the short answer is that if they didn't have different ways to do it, how would you distinguish between them, right? Like, it's the only way to really like write them. It's the only way to actually implement those features is to have them written differently.
Oh yeah, no, sorry. Maybe it's hard to type what I meant, Jacob. It's just like in other languages, like access modifiers, it's kind of just one word, and then it obviously achieves different types of access. But in this finding cadence is like different ways to write the same thing.
Oh yeah, so you're talking about like why is there like access all and pub?
Yes, exactly.
Yeah, I have no idea to be honest with you. I think it's because I think maybe the reason is because like, all of them when you look at them all, right? They're all like they all start with access, so access all, right? There's access, contract, they all are access, but I think they realize that people don't want to write this every time, and the two most common access modifiers are pub and private. So they shorten them for you. But interestingly enough, no one actually took private and they still write access self. So it just is what it is. But I think it's more of a shorthand that they made for you because they're so common. Um, Now that actually brings me to one interesting point. So we actually skipped over one of them called access account, and the reason for that is because we can't show you this on the playground. But I want to explain to you what this means. So it's current, inner, and other contracts in the same account. So it's a little confusing because on the playground, right, you have each account, like account 2, 3, 4, 5, they all have one contract in their account. This is not like the real world. In the real world, every account can have multiple contracts. So let me show you an example of that. This is on mainnet, so this is like a real example, and this is Flovitar. So Flovitar has one account, right? This is their account right here, and they have 5 contracts in this account. They have Flovitar, Flovitar Component, Flovitar Pack, Flovitar Marketplace, and Flovitar Component Template. So all these contracts are all in the same account. Now, what Access Account means is it's current, inner, and other contracts in the same account. So if we have this diagram, and we have an entirely new contract here, but this is called, some contract 2, and they're both in the same account, right? So both of these things, they're both in like account 0x06 or something. Then if we scroll in here, if we had another variable called access account E, then E could be read in here. And also current and inner. So that's what that means. Yep. All right. So that officially concludes this lesson. Hope that was helpful. And let me bring up the float. Do we get into smart contract and account architecture? A little bit. We do when we start getting to NFT collections. That's like our first real example. So the password for this is access control, all lowercase, all one word. So I'll put it here. It's access control. Alrighty. I've learned to put the access control like not in the Discord chat because bots love to copy and paste it into their Telegram group chats. Yeah, I should do that, Bam. I should start doing that. All right, everybody. Yeah, you too, DD. Have an awesome weekend. Play some video games if you do that. If you don't, get outside. Do some fun activity. I don't know what you all like to do. Random stuff. Watch some TV. Be lazy. Don't be lazy. Be active. Go with your friends. Don't see your friends. Be a loner. Be a stoner. No, don't do that. Complete chapter 3. Yes, do that for sure. And catch up on the course. Yes, MPI productivity. Let's go. And I'll see you all on Wednesday. So have a great weekend. Have some fun. Remember to smile here and there. And peace out. See you all on Wednesday. Bye bye.